So in the previous session, we have seen that what are all the top 30 most common words occurring in our dataset or a data frame. So and we saw that great is the most common word which is occurring around 35,000 plus times in our dataset. Now it's time to view the opposite end of this particular thing. So now that we have seen the top common 30 words, now it's time to see top 30 rarest words. So by the intuition, the rarest words would be a very different word that people generally don't use, or there is a second option. The word belonging to the rarest category would be the spelling mistakes. So generally, when a person comes to write a review, he will be generally at the intuition, at a chance of committing a spelling mistakes basically. So generally, we can see that by seeing a rarest count or a rarest top 30 rarest words in our dataset. So what I'm going to do uh, for for top 30 common words, what I have done, this step remains the same even for the top 30 rarest words. The only thing we are going to change is the subsequent thing, that is, so as I said, so this is the same thing. Then frequency distribution all words. Then this remains the same again. So the one thing I'm going to change over here is the n smallest. So when I'm taking a d, that is this d, I'm going to pass it over the plotting, that is plotting of the bar plot. So data which I'm going to pass. So I'm going to pass the data where the words data frame dot n smallest. So n smallest and the columns equals to count. So what does it will do? It will take the smallest count available in the given column. So count is our column. So it will take the smallest values from that column. So that I am going to store it in D. The similar thing I have done for the top common words, top 30 common words. So instead of n smallest, I have taken n largest. So this is a function available within a data frame. So that's why you can use df.n largest. You'll get an idea what this particular function will do. So I have done the similar way. So I have taken n smallest and passed the column value as count. Then I have plotted a figure of size 20 is to 10. Then I'm going to plot a bar plot passing this data with x axis as count and y axis as words, and I am setting the label as word. When I plot this, you could just see these are all the rarest forms of words or the rarest occurrence of the words present in our dataset. So and the count of these rarest words is exactly 1. What does this mean? These words are actually appearing only one time within the entire dataset. So as I mentioned, there might be two chances for the word being rarest. One, that is the exclusively used vocabulary word, like some of the linguistics, some of the person where he is very knowledgeable in the English language and he uses a very peculiar form of that word or rarest form of that word to give the review. That is the first case, and the second case would be the spelling mistake, right? So here you could see in our case it is almost the spelling mistakes. So here the user wanted to say we were, like, were both. So but instead of writing it were both, he added a v in between. So this also you can see the disappointed spelling is wrong, absolutely spelling is wrong, warm feeling. So there should be a space, warm feeling. So but he or she has used in a single word. Experience spelling is wrong. You could just see the spelling mistake or the mistakes in the spelling of the word is the rarest form of the word present in our entire database, and you could just see it has occurred only one time in an entire data set. So now that we have seen two phases of a data frame with the top 30 common words and top 30 rarest words. Now, by this you could have already understood what we are trying to approach. That is, we are trying to yield or get a value called TF-IDF or inverse document frequency, term frequency and inverse documents frequency. That is, we are basically converting the textual data into numerical form. The TF, or in other words, what we can see, we are trying to extract the features from the given data set. That is, this process is called as feature extraction. So for that, what I'm going to do, I'm going to yield TF-IDF value. So for to define TF-IDF value, we need term frequency and inverse document frequency. So let's do that at the very first step. So what I'm going to do, it will start from here. So I'm taken each and every word. I'm going to split that based on the spaces. That is done. Then what I'm going to do, I'm going to take a sum along the axis 0. Axis 0 indicates the row. So once I get that, I will be getting a word in one column, the term frequency or that word occurrence of that word in the entire data set on the other column. That is, it will be in the form of key and value. That's what we can see. So I'm assigning that columns with particular names, that is words and TF as a term frequency. So when I print that, you could just see these are the words and the term frequency or the occurrence of that word in the entire data set is given by the term frequency column. So you could just see awesome is the word which has occurred only one time in the first sentence. So it will take each and every sentence and it will try to plot or map a word associated with the count in the given order. So now we have term frequency. Now it's time to do the inverse document frequency. So inverse document frequency is the number of words present in a particular document divided by total number of documents. So since it is the inverse document frequency, the ratio is reverse. So total number of documents containing the total number of documents divided by number of documents which exactly contain the term. So this is what the inverse document frequency defines. The formula says that it is a ratio of total number of documents or total number of sentences, in our case it is a sentence, divided by number of documents containing a particular term. Suppose if I take a word awesome, so the denominator would be number of sentences that actually contain the word awesome. And the numerator would be all the sentences. That is the entire data set. So for that, what I'm going to do, that is what I am trying to do over here. DFTF shape 0 divided by length of. So what this will do, it will take a length of or what this shape. You could just see on the very first when I say shape, this is a tuple, right? This shape yielded me a tuple. What this tuple indicates, the very first value is the number of rows and 25 indicates the number of columns. So that's why what I am going to do in the inverse document frequency according to the formula. So I have taken DFTF, that is the entire words, that is the total number of words, the shape of the and picking up the 0. What does this means? It will take the row count. Shape of 0 will yield the row count or total number of words present in the entire data frame divided by what I am going to do according to the formula, number of documents which exactly contain that particular word. So that's why you could just see this data frame, that is review data frame string dot contains that particular term. So if I am taking a word, I am going to pass that word, and if this particular sentence actually contains that particular word. So I'm just going with the formula. That's it. I have taken the total number of documents, that is number of documents divided by number of documents which exactly contain that particular term. So if I keep on iterating with this, I'm going to get a value. So why I'm taking a log over here? The TF-IDF value is basically, TF-IDF value is a multiplication of term frequency into log of inverse document frequency. That is TF into log of IDF. So that's why I'm doing that step over here itself. So np.log of inverse document frequency will yield me IDF value. So now to arrive at TF IDF value, now it's pretty simple. I have to multiply the term frequency with the inverse document frequency. So that's what I'm going to do over here. You could see DF TF, that is TF IDF equals to DF TF of TF into DF TF of IDF. So that's what I'm going to store it here, right? So I have stored IDF value as IDF and term frequency as TF. So I'm going to take that and multiply it directly. So when I multiply it, I'm going to get some unique values or numeric form of each and every word. That is, we have feature extracted the word into numerical form. So why we actually convert the words into numerical form? The major intention behind this is to apply deep learning algorithm or deep learning steps. In other words, in order to feed the textual data into the deep learning, we basically convert the textual data into numerical form. So that's what I have done over here. So now the word way has a unique numerical value as minus 5.925. So this will be very unique for each and every word. That's what it shows. Now we have extracted the features from the given word. We have a little modification or a correction to be made within the entire data set. That is, as I observed, there are mismatch in the data format, basically date time format in the particular rows. So that's why I am going to convert or replace the haphazard form or other form of date time into Python date time format. So this will be a form of date time present in our data set. If you could just overview the data uh, in the first step. Okay, where could I see the data set? Here you could see the time formats, that is date added, is in this format. I don't want in this particular format. So I want it in a standardized form, right? So that's why I'm going to replace all these values or 00Z format values into Python date time format. So that's what I'm going to do over here. I have converted those date time formats basically. And I have converted the date here. It's time for time. So I have converted the date into particular format. I am converting the time also into particular format. So this is how my date and time value looks like at the end. So this will basically helps in analyzing as well, right? So if I take a actual date time column present in the data set as it is, it will be very difficult to feed this particular data format into a deep learning network, right? That will be very difficult. So that's why I'm going to convert this into one particular standardized form. That's what I have done in this particular step. So in the next session, what we are going to do, we are going to take a step ahead. Now we have finished the cleaning of the text. Now we have also feature extracted the text, that is feature extraction of the text is done. Now it's time to take a next step, that is exploratory data analysis. So what exactly exploratory data analysis deals with? We try to jump deeper and deeper into our data, and we'll try to get more insights about the data by plotting various graphs. So exploratory data analysis is nothing but a plotting of terms with respect to other terms, keeping one term at the x-axis and y term. We keep on changing the y term. We're going to get the relationship between each and every column. So exploratory data analysis actually does that. We try to relate each and every column with each and every other column, and we try to analyze how each and every column is dependent on each and every other column. So that's what we are trying to do in this exploratory data analysis in the next session.